Okay. So today we are going to discuss a new topic, magnetic field. So my dear, this chapter is exactly similar like the previous chapters. For example, in chapter number 21, we studied the concept of charges. So how many charges we have? We have only two charges, positive charge and negative charge. So please, my dear, when you study chapter 28, please compare the chapter from 21 to 23 or 24. When you compare the chapter from 21 to 24, the whatever the things you discussed in that chapter, we discussed in that chapter, which will be exactly similar in chapter number 28 and 29. For example, in chapter number 21, we studied the charges, positive charge and negative charge. But when you come for chapter number 28, we are going to talk about the magnet. So if you have a magnet, for sure it has only two poles, north pole and south pole. In charges, we have two charges, positive and negative. So in magnet, we have two poles, north pole and south pole. If you take a charge, there will be some electric field. Likewise, if you take a magnet, there will be magnetic field. So whatever the things we studied in that chapters, which will be exactly similar in this chapter. So please, my dear, don't try to memorize. Just compare and study. In chapter number 23, we studied Gauss law. Here we are going to study the Ampere circuital law. So that means the amperes, the Gauss law is for studying the for used for finding the electric field, and here we are going to use the Ampere circuit law for finding the magnetic field. So likewise, it's whatever the things we studied in the earlier chapters, it will be exactly similar in this chapter. So let's we compare and just get some idea in this chapter. So in this chapter title is magnetic field, and what are the topic we are going to discuss in this chapter? We are going to discuss only few topics. We are going to get a small introduction, and then we are going to study what should be the magnetic field created by the current carrying coil. If you have a coil, if that coil have current, what should be the magnetic field? So that things we are going to study in this topic, and then we are going to study the magnetic force equation, like what magnetic we have the electric force equation. So likewise, we have the same type of equation in magnetic field also, that is nothing but the magnetic field force. And then we are going to study it. If a charge is moving in the uniform magnetic field, what will be the case? It's exactly similar like your experiment number 9, E over M measurements, and you studied something in that experiment, and the same thing we are going to see in this topic. And finally, we have to conclude this topic with studying the magnetic force on the current carrying wire. So you have two equations for magnetic force. One is for the charge moving in the magnetic field, and the second formula is related with the current carrying wire. If you have a current carrying wire, what is the magnetic force equation? Likewise, if you have a charge, when the charge is moving in the magnetic field, what should be the magnetic force? So you have two formulas, and inshallah, once I complete this chapter, I will just recall all the formulas what we are going to study in this chapters. Let's we start with the first slide. It's just an introduction, and we are just going to get small information. So that means it's a comparison of the previous chapter with this chapter. For example, you can just see this picture. We have a magnet which has north pole and south pole. Likewise, if you have charges, you have positive charge and negative charge. And when you have a magnet, this magnet should be surrounded by the magnetic field. So that means your magnetic field will be start from the north pole and it will be end in south pole. Outside the magnet, your magnetic field lines will start from north pole and it will be end in south pole. Likewise, inside the magnet, your magnetic field will start from north pole and it will be end in it will be start in south pole and it will be end in north pole. You can just see the arrow mark. The arrow marks is very, very important. Outside, it start from north to south. Inside, it will be start from south to north. And the third important thing, we have to study the concept of magnetic field. It's a vector quantity. It has direction as well as the magnetic direction. So it has the direction as well as the magnitude, like electric field. So let's we just read point by point, and let's we just compare the things which we already studied in chapter number 21, 22, and 23. Let's we start with the first point. What is given in the first point? The area around the magnet within which any other magnet can feel its magnetic force. For example, if you take two magnets, when you place two magnets near to each other, what will happen? Sometimes it may be attract, sometimes it may be repel. Like charges, if you have positive and positive charge, what will happen? It will repel. So likewise, if you have two magnets, because you will never get any magnet with only one poles. Whenever you take a magnet, for sure it has two poles. One is north side and another one south poles. So for example, if I place another magnet near to this magnet, what will happen? The north pole of the first magnet and the north pole of the second magnet, when I just kept near to each other, what will happen? It will start repelling each other. Likewise, south pole of the magnet repel with the south pole of another magnet. If I place the south pole of one magnet to the north pole of the another magnet, what will happen? It will attract. So we already studied this topic in chapter number 21. Like charges repel each other, unlike charges attract each other. So likewise here, the like poles always repel, unlike poles always attract. And then we have two poles here, like positive and negative charge. So that means if you have the two poles, for sure it has some magnetic field lines. And these magnetic field lines are closed. You have to see this picture. Our magnetic field lines start, you can see here, it will start from outside and it's like a loop like structure. Outside the magnet, it starts from north to south, and inside the magnet, it will be start from south to north. That means if you take one loop, it will be closely looped. So that means the magnetic field lines is always a closed one. And then the magnetic field lines emerge from north pole of the magnet and enter to the south pole. You have to see this picture. It will start from north pole and it will be end with south pole outside the magnet. Likewise, inside the magnet, what we are going to get, we have the magnetic field lines starting from south pole to north pole. And likewise, if you want to find the direction of the magnetic field lines, for example, I want to find what should be the direction of at this point P. So what you have to do, in the curved surface, if you draw a tangent line, and that line indicates the magnetic field, the direction of the magnetic field, because it is the vector quantity. It has the magnitude as well as the direction. So close to the magnetic field lines, the field line strength will be stronger. When you just going away from the magnetic field lines, what will happen? Then the force between these two will be weaker. So whenever you come close to the field lines, it will be stronger. When you just go away from the field lines, it will be get weaker, like what we studied in the previous chapter. This is just an introduction. So whatever the things we studied in the charges, it will be exactly applicable for this chapter also. But charges, we have to consider positive and negative. Here we have to consider the poles, north pole and south pole. Now, for example, if you have a wire, you have to see this picture. If you have a wire, and you have to see this wire is carrying the wire is carrying the current, for example. So how to find the direction of the current? So what you have to do, you have to use your right hand rule. You have to see this picture. When you just hold the wire, the thumb indicates the direction of the current, and all the fingers, curved fingers, you have to see our fingers are curved in here. So all these curved lines indicates the direction of the magnetic field lines. So whenever a coil carrying the current, the coil should be surrounded by the magnetic field lines. That means it must have the magnetic field lines when the coil is having the current. So we have to use our right hand rule for finding the direction of the current, and also the finger curling around the wire indicates the direction of the field line. So you have to see here, my dear, the thumb indicates the red color. That means here the red color is the direction of the current. And likewise here, all the blue color lines indicates your fingers, the rest of the fingers which will be curling around the wire. So all these never intersect with each other. Your magnetic field lines, your electric field lines never intersect with each other. Everything will be separate with some distance. No two lines will never intersect. All the times your electrical field lines and the magnetic field lines are not intersecting or not joining with each other. Everything will be separated. Now we are going to study what should be the formula for the magnetic force. My dear, please go back to your chapter number 9, the experiment number 9, because in experiment 9 we just use this formula, because you already experienced that experiment, because we do that experiment in the dark room and you saw the path of the beam, the electron beam in the circular path. So whenever the charge entering the magnetic field, what will happen? It will undergo the centripetal force. That means it will undergo the circular trajectory path. That means it must have the radius. So the topic what we discussed in experiment number 9 is exactly from this chapter. So what is the title of this slide? The force on the moving charge. That means if a charge is moving in the presence of the magnetic field, what will happen? The charge will undergo some different type of path. And my dear, here we have to use right hand rule and left hand rule. For example, here if you consider the positive charge, because in the title I just simply mentioned the charge, What type of charge? Because we have positive charge and negative charge. If you consider the positive charge, then you have to use your right hand rule. If you consider the negative charge, then you have to use your left hand rule, because you have to see here your fingers is moving in the direction of the speed, and when you curl this direction in the direction of the magnetic field lines, what will happen? Your thumb indicates the magnetic force. So two things you have to keep this information in your mind. If you consider the magnetic force for the positive charge, you must use your right hand rule. My dear, the problem, we just conduct the class through online class, but if you have classes in the physical mode, you can see how we have to use our right hand rule. You do one thing, if you just go to the YouTube and please just type right hand rule for the charge and the left hand rule for the charge, then the directions indicated, it will be given clearly explained in that YouTube video. But unfortunately, we are just taking the class through online, so it's not possible to show the exact the working principle of our right hand rule and the left hand rule, but here I gave the picture. So, but keep this information in your mind. If you take a positive charge, you have to use right hand rule. If you take a negative charge, you have to use the left hand. And the most important thing, when you just study the concept of the magnetic field, my dear, sometimes we mention the diagram with dot and cross. My dear, don't get confused about this dot symbol and the cross symbol. Whenever you have the dot, the magnetic field lines are coming out of the page. Whenever you have the cross symbol, the magnetic field lines are going into the page, because we have to show, whenever you just show these type of things in the three-dimensional view, we can just have a look. But when we just explain this topic in the two-dimensional point of view, we can't explain. That's what in all the books, whenever you take the concept of this magnetic field, they indicated this dot and cross. What is this cross dot indicates? The magnetic field lines are coming out of the page, and cross symbol indicates the magnetic field lines are going into the page. So here, whenever you are just having the charge in the presence of the magnetic field, it will undergo some magnetic force. So you will get some magnetic force. So the most important thing, the equations are given as the magnetic force. F stands for force. Here B stands for the magnetic field. So the magnetic field should be indicated with the letter B. In chapter number 22, what we used? We use the symbol E. This is nothing but electric field. So here we are going to use the concept of magnet. So we have to consider the magnetic field, which should be indicated with the letter capital B. So here, what we are going to do, we are going to get the equation for the magnetic force. So how to get the magnetic force? Three things are very, very important, because this is a moving charge. If the charge is not moving, you will not get the magnetic force. And the most important thing, the speed plays an important role. So whenever the charge will have the speed or velocity, and when the charge is moving in the presence of the magnetic field, what will happen? It will have the cross product equation. So you have to see here, Q stands for the charge, V stands for the speed or velocity, and B stands for the magnetic field. And here, this V cross B is a very, very important phenomena, which is nothing but the cross product. For sure, the angle between, if you want to get the highest magnetic field, magnetic force, if you want to get the maximum magnetic force, my dear, the angle between this B and V should be 90 degree. If the angle between the magnetic field and the speed will be 90 degree, then your magnetic force will be maximum. So if you want to get the maximum, because we already studied in chapter number 3, vector A cross B. What's the formula for A cross B? AB sine theta. So likewise here we have V cross B. So Q VB sine theta. Theta or phi. So both are same, because here this theta and phi indicates the angle. If you want to use theta, no problem. If you want to use the angle phi, no problem. Both will give the information about the angle. So now you have to see, when we just apply this rule for this V cross B, we will get magnetic force, which is equal to charge multiplied by VB multiplied by sine theta. If your sine theta is 90, what will happen? Your magnetic force will be greater. Whenever the angle between the speed and the magnetic field will be lesser, then your magnetic force will be weaker. If there will be no angle, my dear, there will be no magnetic force. So through this formula, you can calculate the magnetic force. If you just rearrange this, for example, I want to calculate what should be my magnetic field. So you can rearrange. Once you know the magnetic force, once you know the angle, once you know the speed and charge value, when you just rearrange this equation, you can find. So you can find the value of the magnetic field, you can find the magnetic force, everything is possible by rearranging the equation. And the unit for the magnetic field is Tesla, because Tesla is the SI unit for the magnetic field. It's a 1 mark theory question. Clear? And then we are going to use this formula for the rest of the calculation, because we are going to study few more equation by applying this magnetic force. My dear, you have two magnetic force equation. Yes, my dear.
What is the symbol of Tesla, doctor?
What's the
Symbol of Tesla.
T?
May you write it?
Tesla, T.
Okay.
Clear? T stands for Tesla. It's a unit for the magnetic field. Clear? Okay. So we are going to study two magnetic force. Please, my dear, when you get any question from this chapter, please read the question. If the question is related with the charge or the current carrying coil, if the charge is represented in the question, then you have to use this formula. If the question is mentioned about the current carrying coil, then you have to use another formula, and that formula is the last formula in this chapter. So we are going to study all the formulas, but the most important formula is this magnetic force for the moving charge. Now you have to see, we already did this experiment in experiment 9, the calculation of the charge over mass ratio. So here what we are just going to do, we are going to equate the magnetic force and the electric force. So when the charge is coming, you have to see this picture. When the charge is coming here, what will happen? It will have the speed. And when you have the magnet, you can see here, my dear, all the cross product, cross symbol. What is the meaning for cross? The magnetic field is going into the page. So here you have to use the right hand. If you just take the charge as a positive, then you have to use your right hand. If you take the charge as a negative, then you have to use your left hand rule. So you have to see here, you have the positive, you have two plates. One plate is positive charge, another plate is negative charge. What will happen? If you take the positive charge, what will happen? The positive will get attracted with the negative plates. If you take a negative charge, the negative will get attracted with the positive plates. At the same time, when the charge will be entering the magnetic field, it will undergo the circular path, because we already studied these things in the experiment number 9. That's what this curve symbol is given here. When you just adjust this magnetic field and the electric field, what will happen? Your charge will be exactly come and hit this area. So that means we have to equate two forces. And you already familiar about this equation, which we already studied in chapter number 22, which is nothing but the electric force. Electric force, which is nothing but electric field multiplied by the charge. Magnetic force, which is nothing but Q V cross B. So this Q V cross B is nothing but Q VB sine theta. When the theta is 90, then you will get the maximum magnetic force. So my FB, that means my magnetic force, which is nothing but QVB. So what I am just equating, I am just equating my magnetic force equation and the electric force equation. By that, we will get this equation. Suppose if you want to find the relation between the electric field and the magnetic field, then you have to see here, my dear, this charge get cancelled with this charge, and finally what will happen? You will get the relations connecting the electric field and the magnetic field. So this is our equation. How we got this equation? We compared two equations. What is our equation? Electric force equation. We already studied Q multiplied by E. And what is the equation for the magnetic force? Which is nothing but QVB. Sine theta is 90 degree if you want to get the maximum force. So when you just equate these two, what will happen? This two charge left hand side and the right hand side will be get cancelled, and by that you will get the relation connecting the electric field and the magnetic field. Inshallah, I will recall all the formulas once I just complete this chapter. Now what will happen when the charge will be entering the magnetic field? You have to see, I told you, you can just use this cross symbol and dot symbol. The cross symbol indicates the magnetic field is going into the page, and this dot symbol indicates the magnetic field is coming out of the page. So if you just use whether the cross or dot, the concept will be the same. So what will happen when the charge entering this magnetic field? You can see here, my dear, we have a lot of dot symbol here. That means the magnetic field is coming out of the page. So what will happen when you just make a charge, when the moving charge is entering this magnetic field, what will happen? It will undergo the circular trajectory, and you already experienced these things in experiment number 9. We have a very good, beautiful green color circular path. When you just do that experiment in the last week before the Eid holidays, I hope you remember that experiment. We have a very good circular path. So that is nothing but the centripetal force. So how we got this equation? By these two equations. Which equation? We have to use our magnetic force equation just before we studied, and also we have to use our centripetal force. And you already studied the centripetal force in physics 1, chapter number 4. So the left hand side is also the force, the right hand side is also the left hand side of the two equations indicates the force. So what I am going to do, I'm going to equate the right hand side of these two equations. So my right hand side of the first equation is QVB, my right hand side of the second equation is mv square over r. So now what will happen? we can find what should be the equation for the radius calculation. So you have to do some simple calculation. So what I'm going to do, I'm going to cancel this speed with speed. So when I just cancel with the speed with speed, what will happen? One thing, I think I have to remove these things. So when you just remove one speed left hand side and another speed in the right hand side, you will get this equation like this. Am I right? Am I right or not? By mistakenly I just include this v. Just please my dear, if you have a slide printout, you have to delete this. So when you just cancel the speed left hand side and the right hand side, then you will get the equation qb, which is equal to mv over r. When you just rearrange this equation, we can get the equation for the radius calculation. So if you want to calculate the radius, what are the things very needed, my dear? The charge mass is very important. If you take an electron, then the mass of the electron, it's a constant value. And then if the speed is given, then you have to use the speed value. And charge value, we know 1.6 multiplied by 10 to the power of minus 19. And here we are just using only the magnitude value of the charge. And V is the amount of the magnetic field present when the charge entering the magnetic field. What should be the uniform magnetic field value? Once you know the mass, speed, magnetic field value, and the charge, you can easily calculate what should be the radius of this circular path. You have to see this picture. It's a very good, beautiful circular path. So for sure, if you have a circular path, you will have the radius value. Now, once you know the radius, you can easily find the speed also. How to find the speed? Because we already studied the formula in physics 2, chapter number 2, physics 1, chapter number 2, speed, which is equal to distance over time. And here the distance is nothing but, for example, you have to see this picture, my dear. It will undergo the circular path. Am I right? The charge will go in the circular path. So how much distance starting from this point to this point, which is nothing but the perimeter of the circle, 2 pi r. So when the charge is undergoing the circular path from this point to this point, how much the value of the formula, which is nothing but 2 pi r. This is our distance. And the time is nothing but t. So we have the formula t, which is equal to 2 pi m divided by qb. So how we got? I'm just using only the formula here. In the place of r, I took this value of r. What is our r? R, which is equal to mv q multiplied by v. So what I'm going to do, I'm going to take this r value, I'm going to substitute the value. So what is our r value? Better I can just work out here. My r value, just before we studied, mass, speed divided by charge multiplied by v. So what will happen? Take this r value, substitute here. So if you substitute, what will happen? My speed, which is equal to 2 pi, in place of r, I'm going to substitute this value. So what I'm going to do, mv, in place of r, I'm going to use mv qb, and in the denominator we have time t. So what will happen? You can just cancel the term. So which term we can cancel, my dear? Is it possible to cancel? So if you rearrange this equation in terms of time period, so what you'll get? My time period, which is equal to 2 pi mv divided by v qb. So what will happen? This v get cancelled with this v, and finally you will get the equation for the time period. So when you cancel this v from top and the bottom, the numerator and the denominator, you will get this equation. And the most important thing, so here we have to cancel this v and v. Finally we got the value. So how we got this? Because this v get cancelled with this v, and finally we got. So that means if you want to get the time period value, you must need the radius. So where we got all this formula? With the help of the centripetal force and the magnetic force equation. When you compare these two equations one by one, we will get easily. First we will get the radius. Once you know the radius formula, you can easily find the time period. Once you know the time period, calculating the frequency will be very easy, because frequency, we know frequency, which is nothing but the inverse of the time period. And what is our time period, my dear? Just before we find the time period formula, t, which is equal to 2 pi m over qb. Take this t, substitute here. So what will happen? My frequency, which is equal to qb divided by 2 pi m. So we will get this equation. And once you know the linear frequency, angular frequency, we know the formula, which is nothing but 2 pi f. So take this omega, which is equal to 2 pi f. I am going to take this frequency, I am going to substitute here. So what will happen? 2 pi qb divided by 2 pi m, and this 2 pi get cancelled with this 2 pi, and finally my omega formula, that means my angular frequency, which is nothing but qb divided by m. So that means one by one we can get the formula very easier. But the most important thing, you must know the first equation and the second equation. If you forget these two equations, getting the rest of the formula will be very harder. That means the main two equation is nothing but the magnetic force equation as well as the centripetal force. So once you know the magnetic force and the centripetal force equation, the rest of the formulas you can easily calculate. But my dear, listen carefully. This formula has different parameters. So please don't get hurry. For example, if you got any question from this chapter, please relax while you solve the problem, especially the radius, mass, B, charge, as well as the magnetic field, this value. If you miss one of the parameters, then the calculation of the radius will be wrong. Once the radius will be wrong, then your time period will be wrong. Once the time period will be wrong, your linear frequency will be wrong. Once the linear frequency will be wrong, then your angular frequency will be wrong. So please do your calculation very carefully. That's a very, very important thing. Clear? So we have some questions by using this value, these formulas. Inshallah, please memorize the formula, because especially in physics 2, you are going to study more number of formulas. So please, my dear, it's in your hand. If you miss any formula, if you forget any formulas, then you will be in trouble. And finally, we are going to conclude this chapter by studying the formula of the second magnetic force. My dear, first magnetic force, we studied the magnetic force related with the moving charge. But here, we are going to study the magnetic force based on the current carrying wire. For example, you have to see this picture. Here we have a wire, and this wire has some length. And my dear, the current is moving here from here. You have to see the direction. And here, all this dot symbol indicates, you have to see this, all this dot symbol indicates the magnetic field is coming out of the page. You have to use, if you have a positive charge, you have to use the right hand rule. If you have the negative charge, you have to use your left hand rule. So when you apply the left hand rule or right hand rule, what will happen? You can find the direction of the magnetic force. Always the thumb indicates the magnetic force direction. So how we got this equation? Because we are going to use this formula for the magnetic force calculation. So how we can calculate? Again, we have to use the same formula. Which formula, my dear? We already studied the formula of the charge. Do you remember this equation? Charge, which is nothing but current multiplied by time. We already studied this equation in chapter number 21. So here, what I'm going to do, I'm going to take the charge formula, and in this place of time, I have to use this formula. What's the formula for the speed? What's the formula for the speed, my dear? Speed, which is nothing but distance over time. Therefore, my time, which is equal to distance divided by speed. Am I right? What's the distance here, my dear? Here, my distance is nothing but the length of the wire. So in this place of time, what I'm going to do, time which is equal to, in this place of d, I'm going to put length is my distance, and what is the speed? Because here we are talking about the charge is moving. So this speed is nothing but our drift speed. We already studied this drift speed in chapter number 26. So I have to take this time formula. I'm going to substitute here. If you substitute, what will happen? Q, which is equal to I multiply by length divided by drift speed. Now, I'm going to take this charge, I'm going to substitute this formula in our magnetic force. What's the magnetic force, my dear? Just before we studied, Q V B sine theta. So take the charge, substitute here. So this is our charge. When you take the charge, when you substitute here, what will happen? When you consider the theta is 90, so your sine 90 becomes 1. And when you take the charge, when you substitute here, what will happen? My magnetic force based on the length of the wire, which is nothing but I multiply by L divided by drift speed. And again, we have the drift speed, because here speed is nothing but the charge of speed, and which is nothing but the B. Drift speed get cancelled with this drift speed. And finally, I will get the formula FB, which is nothing but ILB. So you have two formulas for magnetic force. If the question is related with the moving charge in the magnetic field, then you have to use FB, which is equal to QVB sine theta. Suppose if the question is related with the current carrying wire, then you have to use the formula FB, which is nothing but ILB. Again, here, my dear, the most important thing here, LB is nothing but the length is a constant. I cross B is nothing but here the cross product. Here also the sine angle plays, because whenever you have the cross product, you will get the sine parameter. So please read the questions very carefully. If the question is related with the charge moving on the magnetic field, then you have to use the first formula. If the question is related with the current carrying coil, which has the length of the wire, then you have to use this magnetic force. So everything will be given clearly in the question, but you have to choose the formulas in your hand. Whether the question is related with the charge or the current carrying wire, then you have to choose the formula very carefully. Clear, my dear? That's it. So these are all the problems we are going to use. These are the formulas we are going to use in these three formulas, three questions. And anyhow, I will just recall all the formulas one more time. Could you please tell me what is the formula for the magnetic force? Magnetic force, which is nothing but Q V cross B, or Q VB sine theta. And if you have a magnetic force with a current carrying wire, which is nothing but I LB, which is nothing but how we can write this equation in terms of cross product, my dear. How we can just write this formula in terms of cross product? I have to write this formula like how we can write. I can write this
I
formula
times L cross B.
L cross B. Very good. So F, which is nothing but I times L cross B. That means the angle between the length and the magnetic field is very, very important. If you maintain the angle between the length of the wire and the magnetic field is 90 degree, then you will get ILB sine theta. When theta is 90, you will get the magnetic force greater. That means maximum greater force you will get. And then we have to use the formula. What is the centripetal force, my dear? M V square over R. When you just equate these two equations, you will get the radius. What's the formula for the radius? Radius, which is nothing but mass multiplied by speed divided by the charge multiplied by the magnetic field. And then by using this radius, we have to use the time period formula. Time period, which is nothing but distance over time, distance over speed. Am I right? Am I right or not? Distance over speed is the value. So if you just have the value, because here the d is nothing but 2 pi r divided by v. When you just take the r value, when you substitute here, what will happen? Your time period formula becomes 2 pi m divided by q multiplied by b. Once you know the time period, you can easily find the frequency value, which is nothing but the reciprocal of the time period, which is nothing but qb over 2 pi m. And finally, when you just use this frequency for the angular frequency, my angular frequency omega, which is nothing but qb divided by m. So you have to memorize this formula. This is one of the important formula, and this is your second important formula. This is your third important formula. This is your fourth important formula. And my dear, these two formulas are very, very important. So please read the question. If the question is related with the length of the wire, you have to use ILB sine theta. If the question is related with the charge speed in the magnetic field, then you have to use charge speed magnetic field multiplied by sine theta. So these are all the formulas we are going to use in this three question. So can we start solving the question, my dear? Because the time is very short, so we have to finish our chapters very quickly. So still we have only 2 weeks and 3 days. So at least I have to complete this chapter by next week. I have to try to complete the chapter by next week. Inshallah, in the third week, we have 2 classes. In that classes, we can just have some revision about the final theory exam. I will give some instructions about the final theory exam. Clear? Clear, my dear? Is it clear?
Yes, yes, doctor, clear.
Yes, doctor,
Okay.
clear.
Let's start the question. First question, because all the questions what we chose is very easiest question, because we always favor for the student, because we never ask that much difficult question in the exam. The only thing you have to take the practice, my dear. Without practice, it's very hard to get full marks in the final theory exam. So please take practice. That's a very, very important thing. Okay, let's start solving the first question. What are the things given in the question? And this question is related with the magnetic force. So we have 2 formulas for the magnetic force. So which formula we are going to use? That's a very, very important thing. Let's see what is given in the question first. The wire 2.3 meter long. That means the length of the wire is given. What's the value, my dear? 2.3 meters long. And it has the current value. What's the current value? 13 ampere. And the angle value is given as 35 degree, and the magnetic field value is given as 1.5 Tesla. That means you have the length of the wire 2.3 meters, and which is carrying the current is flowing through that means the current is passing through the wire, and the amount of the current is 13 amperes, and the angle kept between the wire as well as the magnetic field is given as 35 degree, and the most important thing, you have the uniform magnetic field as 1.5 Tesla. Now you have to use your magnetic force formula for calculating the magnetic force. My dear, we have two formulas, FB, which is equal to QVB sine theta, and also we have another formula which is nothing but ILB sine theta. My dear, which formula is exactly applicable for this question? First one or second one?
The wire.
Why second one? What's the reason?
Wire.
Because they give the length of the wire, they give the information about the current. But if you want to use the first formula, it's not possible. Why? Because here the speed and the magnetic field. Magnetic field is already given, but the speed is given. There is no information about the speed. But in this question, they give the information about the current as well as the length. So which formula we have to use? We have to use the second formula. So I am going to use the formula directly, magnetic force, which is nothing but ILB sine theta. So take your calculator, my dear. Let's check the answer. Current value is 13 ampere multiplied by our length is 2.3 meter wire. And then our magnetic, the uniform magnetic field is 1.5 Tesla multiplied by sine theta. Theta here is as 35 degree. So when you just multiply all these things, you will get the answer. And the unit for the force is, what's the unit for the force, my dear? Newton. Good. Could you please tell me the answer for this?
Minus 19.20.
Really?
Yes.
Is there any force with the negative value, my dear?
Yes, because it's vector.
You got negative value? Are you
Yes.
sure? Could you please check your calculator, my dear? Which mode you have the calculator? Which is radian mode or the degree mode?
Radian.
Please convert. Whenever you have the angle information, you have to change the mode in your calculator. Please make the degree mode. If you put the calculator in the radian mode, then your answer will be negative. I need the answer in terms of, my dear, whenever you have the angle, please convert your mode of the calculator in the degree mode. Clear?
25.72.
Okay, good. 25.72 Newton. So this is the answer. So please, my dear, keep this information in your mind. Whenever you have any equation with the angle, please convert the mode to degree. Clear? Let's check our answer. Our answer was exactly correct. Clear? Clear, my dear?
Doctor, can you please go back? Okay, doctor.
Clear? Okay.
Yes.
We got the same answer, and we have to solve the second question. So please, my dear, when you just read this question, then you have to see we have two parts. For the first question is related with the speed calculation, and the second question is related with the radius calculation. But before you just see the question, could you please read the information what is given in the question? My dear, this question is exactly related with your E over M experiment. So in E over experiment, what we had, we gave three different voltages. Do you remember that? First, we gave the initial voltage for making the electron coming out of the gun. Am I right? Am I right or not?
Yes.
We gave three different voltages. First one, we gave 6 volt for making the electron coming out of the metal. Am I right? And the second thing, we gave the accelerating voltage. Why we gave the accelerating voltage? We have to take the electron coming out of the gun as a straight line. And then third voltage, we gave for making the electron to moving in the circular path. So three different voltages we give. Am I right? So my dear, when you just solve this question, you have to just bring what you did in the previous experiment, because here we are going to follow the steps. So we just solve one by one, and by that you will get a clear idea. So we read what is given in the question. What is given in the question, my dear? Just read line by line, word by word. An electron. So they clearly mentioned this is an electron. And the electron is accelerated from rest. So that means initially the electron is at rest. That means you have to accelerate the electron by giving some accelerating voltage. How much voltage you are going to give? How much voltage you are going to give? If you want to take the electron out of the gun, you have to give the accelerating voltage. Am I right? Am I right or not? So the accelerating voltage here we are going to give is 380 volt. That means initially the electron is at rest. Do you remember that? When you give 6 volt, you can see the orange color light in the bulb. Do you remember that? Am I right or not?
Yes.
Yes, doctor.
And after you gave 150 volt, the electron is coming out of the gun. Am I right? So likewise,
Yes.
initially you have the electron which is at rest, but if you want to accelerate that electron, you must give the accelerating voltage, and here the accelerating voltage given in the question as 380 volt. And then the electron, you make the electron to enter this uniform magnetic field, and that uniform magnetic field is given as 200 millitesla. What is the meaning for milli, my dear? The millitesla is nothing but 10 to the power of 3, 10 to the power of minus 3. So that means the accelerating voltage is given, the magnetic field, the uniform magnetic field is given, and they clearly mention, you have to see this, which is exactly the velocity is perpendicular to the magnetic field. That means the V cross B is exactly what's the
90.
angle between V, what is the angle between the speed and the magnetic field? They clearly
90.
mention perpendicular. What's the
90.
meaning for perpendicular? Perpendicular is nothing but 90 degrees. That means the sine 90 becomes 1. That means here you will get maximum electric field, maximum magnetic force. Clear? So now, by using these things, we are going to calculate what should be the speed and what should be the radius. My dear, speed, we cannot be able to get the formula directly, because when you just go back, you can just see, if you want to find the speed, is it possible to here, my dear? Is it possible to get the speed here? It's possible, but we need the radius. Am I right? Am I right or not? Am I right
Yes,
or
yes,
not?
Doctor. Yes,
So
yes.
here, by using this formula, we cannot be able to find the radius, because if you want to find the speed, we must need the radius. But the second question, they clearly given, you have to find the radius. That means you cannot use this equation for 2 questions. So for finding the radius, you can use the direct equation, but for finding the speed, what we have to use, my dear, whenever the electron is at rest, you have to give the accelerating voltage. When you give the accelerating voltage, what will happen to the electron? Which will have the kinetic energy. Am I right? Am I right or not? Whenever
Yes,
you
yes.
accelerate the electron, it will
Yes.
have the kinetic energy. So by using the kinetic energy, what I'm going to do, I'm going to take the speed. So what is my equation, my dear? We know already the formula for the kinetic energy, half mv square is the kinetic energy of the electron. How you can get the kinetic energy? By applying the accelerating voltage. Which accelerating voltage? 1 electron volt. When you just give 1 electron volt, the electron volt, which is exactly equal to the kinetic energy of the equation, because I already explained in the lab classes. I hope you remember that. If you want to take the electron coming out of the gun, you have to give the accelerating voltage. That accelerating voltage is nothing but which is exactly equal to the kinetic energy of the electron. So here you have to see this V is nothing but our accelerating voltage, and here E is nothing but the charge of the electron. So what I'm going to do, I'm going to use this equation, 1 electron volt, which is exactly equal to the kinetic energy of the electron. By using this equation, I'm going to find the speed. So how you can find the speed, my dear? Just rearrange this equation, V square. So please don't confuse about this V and this V. My dear, this V indicates the speed, this V indicates the voltage. So don't get confused about this small 2 V's, okay? The small V indicates the speed and the capital V indicates the voltage. Better I can write the capital V here. Clear? So the speed square, which is exactly equal to 2 multiplied by electron volt divided by the mass of the electron. Am I right? Am I right? Am I right or not?
Yes.
Okay,
Yes,
now
yes,
we need only the speed, so I am going to take the square root on both sides. If I take the left hand side square root, it will become small v, and right hand side, what will happen? Everything comes under the square root. That means now substitute the value, my dear, and the mass of the electron will be given, it's a constant value, and the rest, and E is also the constant value, but the accelerating voltage is already given in the question. So for getting the first question, what I am going to do, my dear, I'm going to substitute the value here, square root of 2 multiplied by 1.6 multiplied by 10 to the power of minus 19 multiplied by, and here electron volt is the one capital V, which is nothing but the electron volt, which is nothing but 380 volt, divided by the mass of the electron, which is given as 9.11 multiplied by 10 to the power of minus 31. Could you please tell me the answer?
11.55.
What's the value, my dear?
11.55
11.55
multiplied
Multiplied by
10.
10 power minus 6.
10 power minus 6 or plus 6?
No, 6.
6. What's the unit for the speed, my dear?
meter per
meter per
second.
second.
Meter per second. Clear? This is our speed value. Once we know the speed, we are going to find the answer for the second question, only the radius. So how to find the radius, my dear? It's very easy because we already have the formula. Radius, which is equal to mass multiplied by speed divided by charge multiplied by b. So I'm going to use the formula directly for finding the second answer because we already studied these things in the theory, which is nothing but r, my radius of the path of the electron, which is equal to mass multiplied by speed divided by charge multiplied by magnetic field. So what's the mass of the electron? The mass of the electron, we know this is a constant value, 9.11 multiplied by 10 to the power of minus 31. Don't worry about the constant value. All the constant value will be given in your exam paper. So 9.11 multiplied by 10 to the power of minus 31. And speed, I am going to take the value from the first question. So what is our value, my dear? 11.55 multiplied by 10 to the power of 6 divided by the charge magnitude value is 1.6 multiplied by 10 to the power of minus 19, and the magnetic field value is given in the question as 200 millitesla. So 200 multiplied by 10 to the power of minus 3. Could you please tell me the answer, my dear? And what's the unit for the radius? Meter. What's the value?
3.29 multiplied by 10 minus 4.
Minus
4.
4. So what's the unit for the radius? Meter. So let's just see the answer. Or if you want, my dear, if you want to cross check your answer, my dear, it's possible. If you want to cross check your answer, we know the radius. Am I right? Am I right or not? So by using the radius, you can find the speed. What I'm going to do, I'm going to take this value, I'm going to substitute here, and mass is a constant, charge is a constant, magnetic field is already given. If you want to confirm whether your speed is correct, when you just substitute all the values, when you check this speed, it will be same like this one. In this way, you can cross check your answer. Clear? Clear, my dear? Clear?
Yes,
But I have a
but
question, please.
which question,
Yes?
doctor? Which equation? You can
This equation. For example, by using the speed, we find the radius. Am I right? Am I
right.
right or not? If you want to cross check your answer, after you find the radius, substitute your radius value, rearrange this equation in terms of the speed, you will get the same answer like this. Clear?
Clear.
But the rule what we follow was exactly correct, because electron volt, without giving the accelerating voltage, you will not get the kinetic energy of the equation, because initially they clearly mentioned your electron is at rest. That means there is no movement of the electron. Till you give this electron volt, one accelerating voltage, the electron will never come out of the gun. Only you can find the spot, light spot will be there. But if you want to take the electron from the gun, what you have to do, you have to give the accelerating voltage. Otherwise, it is not possible. They clearly given in the question, initially your electron is at rest. By giving the potential difference, by giving the accelerating voltage, how much voltage you give, 380 voltage you give, by that you take the electron coming out of the gun. So when the electron is coming out of the gun, for sure the electron will have the kinetic energy. Because kinetic energy refers with the movement of the electron. That means the motion of the electron. If the electron is at rest, there will be no kinetic energy. So you have to give the electron voltage. By taking the electron, will have the kinetic energy, and by that we will get the equation. So that means 1 electron volt, which is exactly equal to the kinetic energy of the equation. You already know the kinetic energy formula in physics 1. And here we know electron. If you want to take the electron coming out of the gun, you have to give the potential difference. Clear? As we check our answer, 11.55 multiplied. My dear, this is not negative. Actually, this is nothing. 11.55 multiplied by 10 to the power of 6. Okay, here I got 1.15, 10 to the power of 7. Both are correct. You gave the answer in terms of 6, but I gave the answer in terms of 7. Both answers are correct. And what is our radius value? 3.29 we got. Here we got 3.27. Maybe some small difference will be there. So both answers are correct. Am I right? Clear?
Yes, doctor. Clear.
Yes, doctor.
Okay, that's good. Now we have to go for the third question. Third question, exactly easiest question. You already familiar about this question, and you already did this type of question in chapter number 3, vectors, cross product. You know IJK method. Am I right? Am I right or not?
Yes.
Do you remember
Yes,
the
yes.
IJK method, my dear? In
Yes,
chapter number 3,
Yes,
A
yes.
cross B. So we are going to play with the same type of method for this question. We just read the question one by one, because here you have two parts. So I am going to work out one by one. So what is given in the question? An electron that has instantaneous velocity of velocity equations, which is given in the form of vector equations. So what is our instantaneous equation of the speed of the electron, my dear? Which is nothing but -5 multiplied by 10 to the power of 6 meter per second I cap vector, plus 3 multiplied by 10 to the power of 6 meter per second j cap vector, is moving through the uniform magnetic field, which is also given in the form of the vector equation. That means my magnetic field equation is also given in terms of the vector form, which is nothing but 0.030 Tesla I cap, because Tesla is the unit for the magnetic field for the x-axis, minus 0.15 Tesla j cap. Now what we are going to do, we are going to find, my dear, listen carefully, we are going to find what should be the force of an electron due to the magnetic field. That means here they give the speed as well as the magnetic field. So we have two formula for the magnetic force. What are the two formulas, my dear? Because you are going to calculate the magnetic force. Here they simply mention the force. Which force? The force due to magnetic force. Clear? We are going to find the force related with the magnetic field. So that means here we have to use two formula. What are the two formula we studied, my dear? Magnetic force, which is nothing but Q V cross B, and second formula, which is nothing but I L cross B. Which formula you are going to use, my dear?
The first one, doctor.
First one, because there is no information about the current and the length in this question, so we have to use only the first equation. But my dear, here there is no information about the angle, so I cannot be able to write this equation QVB sine theta. Why? Because the angle is not given. The equation is given in terms of vector mode, vector formula they give. So I have to take the formula as it is. So what I'm going to do, for making our life easy, I'm going to take the formula like this, which is nothing but magnetic force, which is nothing but charge V cross B. Am I right? So what I'm going to do, first I'm going to find the V cross B. So I'm going, because charge is just multiplication, and once you find the V cross B, we are going to find the charge, because they clearly mention what is given in the first question, my dear. The charge value is negative. That means the electron value charge is negative. What's the value for the charge, my dear? What is the charge value of the electron? Minus 1.6 multiplied by 10 to the power of minus 19 coulomb. Am I right? And second question is related with the proton. What is the proton value?
Plus.
Clear? So I'm not bothering about the charge. First of all, I'm going to give importance for this V cross B. So what I'm going to do, first I'm going to find V cross B, and once I find the V cross B, I'm going to multiply with minus 1.6, because our question is related with the electron, so I have to multiply. So what I'm going to do, better I can use the new page. So better first I find V cross B. So we have to go for IJK method. So what is our IJK, my dear? IJK. And for speed, what is our I value? Minus 5 multiplied by 10 to the power of 6. And for I, for the magnetic field, 0.030. So I am going to write for I, which is nothing but minus 5 multiplied by 10 to the power of 6. And what is my magnetic field, my dear? For the I cap, 0.030. And what is our J value? This is 3.3 multiplied by 10 to the power of 6 for the speed. And for the magnetic field, minus 0.15 for J cap. So I have to write 3 multiplied by 10 to the power of 6. And your magnetic field is minus 1.5. And is there any value of K here?
0.5, doctor. 0.1.
What's the value of K?
Yes, doctor. Doctor, 0.5, 15 for J cap.
It's 15 or 1 point. Oh, sorry.
0.15, doctor.
Yes, I understood. So this is 0.15. Am I right? Okay. 0.15.
Minus, doctor.
Yeah, they give minus. Am I right? See, they give minus.
Oh, yes.
So I put minus. And is there any information about k? K is not given. Here also k is not given. So I have to put 0 for this. So I have to put the k value as 0. So first I have to multiply. You know the procedure, my dear. First you have to left your first row and first column, and you have to multiply. First you have to go in this way, and then you have to go in this way. So if anything is multiplied by 0, what should be the value of I, my dear?
0 I.
So I multiply by 0 minus 0. So whenever you go in the left hand side, it has a positive. Whenever you go to the right hand side, it is negative. And let's come for the second value.
Also 0j.
Let's just go one by
Be
one.
minus j.
So that means this column you have to take. Am I right? Again, this one multiply with this one, 0. This one multiply with this one, 0. So always the second will have the negative value. So minus j, 0, minus 0. When you come for the third one, you will get some value, because you have to leave the first row and the last column, and you have to multiply. When you just multiply these, my dear, could you please take your calculator? I just need the answer. When you just go in this way, it is positive. So could you please tell me the answer? Plus k minus 5 multiplied by 10 to the power of 6 multiplied by minus
75 multiplied by 10 to the power of 4.
75.
75
Okay.
multiplied by 10 to the power of 4.
4. Good. Okay. When you go in this way, it is negative value. So that means negative of, could you please multiply this? 0.030 multiplied by 3 multiplied by 10 to the power of 6.
And 9 multiplied by
10 to the power of 4.
9 10 to the power of 4. So we have to complete. So I value 0, it will gone. J value 0, it will gone. So my V cross B value is only for the K cap. So could you please subtract this? 75 10 to the power of minus 10 to the power of plus 4 minus 9 10 to the power of 4. Could you please tell me the answer?
66 multiplied by
So 66 multiplied by
10 to the power of 4.
10 to the power of 4 K cap. Am I right? Yes. So we find this V cross B, but we need the magnetic force for the electron. So what I'm going to do, my magnetic force for the electron, which is nothing but Q V cross B. So V cross B, we just calculate, which is nothing but 66 multiplied by 10 to the power of 4. And what is the charge of the electron? Minus 1.6 multiplied by 10 to the power of minus 19 multiplied with 66 multiplied by 10 to the power of 4 K cap. Could you please tell me the answer?
Minus 1.056.
056
multiplied by 10 to the power minus 13.
Minus 13, and the unit for the force is Newton, and this is K cap. My dear, listen carefully. Could you please tell me which direction it is exactly pointing? K cap refers for the Z direction. Am I right? Z direction. Am I right? And it has negative. So what should be the direction of the magnetic force, my dear? Negative?
Z direction.
Clear? Clear, my dear? And for the proton, I don't want to repeat the same step because it's very easy, same value, but only thing what you have to do, you have to write the formula for the proton, V cross B. V cross B will be the same, but what should be the charge of the proton? 1.6 multiplied by 10 to the power of minus 19 multiplied by 66 multiplied by 10 to the power of 4 K cap. When you just multiply, you will get 1.056 multiplied by 10 to the power of minus 13 Newton K cap. So what should be the direction for the proton? What should be the direction of the proton?
Positive Z direction.
That's it. That is the information we are going to find. See, calculating the magnetic force, but they did not ask about the direction, but we gave the answer for the direction also. This is the answer for the magnetic force, but which direction your magnetic force? Because it's a vector quantity. You must mention the direction also, because it has both magnitude as well as the direction. Clear? So we check the answer. We have to check the answer. Our answer was exactly correct. I think here I missed something. Am I right? I just missed the power here. So please, my dear, Just put the power here. Clear? Clear? But the answer finally,
Yes,
we
yes.
got the same answer. We got the same answer. Understand?
So, Doctor,
Clear?
okay, okay. For proton, we just put the plus.
Oh yeah, proton value is
Yes,
positive 1.6 multiplied by 10 to
positive.
the power
Yes,
of
yes,
minus 19. Electron is minus.
yes.
Because in
Dexter,
the question they did not give any other. I'm thinking only they just need the magnetic force for the electron. They need the magnetic
Yes,
field for
yes.
the proton. That's it. If you are
Proton.
using the right hand rule for the positive charge, then your right hand rule indicates, your thumb indicates the negative direction of the z-axis. Clear? Because you have
Yes,
to use
yes.
your right hand rule. And if you are using the electron, you have to use the left hand rule. Your thumb indicates the negative direction. Clear?
Yes, Doctor, clear.
Dexter,
Clear, my dear? Yes.
for the direction Z, I didn't get it. How you
You did
do
not
it?
give the, you did not, my dear, watch this negative, my dear. This is the negative value. You got negative
Right.
value. Am I right?
Yes.
What is this K cap indicates?
Oh, Z value, right?
Z value. That means my
Yes.
Z value direction in the negative point. Am I right?
Yes.
Likewise, here we have positive value. Again, what should be the direction of your Z axis? In the positive point.
Okay, so the first one negative and the second one is positive, right?
That's it. Yeah, same,
Okay.
same. Correct. Clear? So that's it, my dear. This chapter was very easy. Please, my dear, don't miss this opportunity because you are a really lucky guys. You know why? Because from chapter number 25 to chapter number 30, we reduced the number of problems because of the Ramadan timing, as well as the time after the Ramadan is only 2 weeks. So that's what in the group, both male branch and female branch, we discussed together to reduce the number of problems for after the Ramadan also. Why? Because only 2 weeks, some doctors, they, because of their time, their class timing, they are just a little bit slow down their classes. So we plan for reducing the number of problems after the Ramadan also. That's what chapter number 29 and 30, we reduce the number of problem. So please, my dear, use this chance and try to get full marks in your final theory exam. Because during the Ramadan time, the last week, we got the continuous holidays. Am I right? So this portion is also included there. Do you remember that? Before your Ramadan holidays, that Sunday and Monday, initially we have a college, and later on it was announced as holidays. Am I right?
Yes, yes, Doctor.
That's the reason. Otherwise, we will not reduce the problem. But anyhow, it's good for you. But please use this chance very in the positive way. Try to get full marks in your final theory exam. It will be very easy. So please, my dear, I would like to tell you something about because still we have time. What's the time? It's only 11:10. My dear, please listen these things carefully. Some students, you are very close to DN. Please, my dear, it's my kind request for all of you. Still, you have 2 weeks and 3 days. If you missed any classes, those who are very closer to DN, I can't do anything. I will check the attendance sheet given by this blackboard. I will enter the attendance in the SIS. And for the lab classes, some students, they thought, okay, this is just a revision lab. I want to take a holiday. My dear, if you have enough attendance, no problem. But if you have a shortage of attendance, please attend the class. And it's just a revision lab. Come and have a look of all the 7 experiments, and please just to get some idea and then leave. Don't lose your attendance. If you are getting DN, please don't come to my office. That's your problem. That's your mistake. So those who are very closer to DN, please be careful, my dear. I will enter the attendance what I have in my attendance sheet. If you are absent, absent. If you are late, it will be late. If the attendance sheet given by the blackboard is absent or late, I will just mention the same thing in the educate. Clear? So this is our first thing. And the second important thing, I have to tell you about the final theory exam. My dear, in the midterm exam paper, I found some students. My dear, listen these things carefully. This word is very, very important. This information is very, very important. For example, let's we take this question. We take this question. My dear, we have this question. We have the formula here. Am I right? For example, take the B part. We have the formula for the radius here. Am I right? Am I right?
Yes, yes,
most
Doctor.
of the student, they never give these steps. They never show what value you substitute for this formula. Most of the students, they write the formula, they immediately give the final answer. My dear, if you give like this, what will happen? You will lose some mark for the substitution. So please, if you have, because most of the question is related with the formula, am I right? So please, once you write the formula, please make the substitution in the formula. Because, for example, if this question carries 1 mark, how we will give the division? Quarter marks for the formula, quarter marks for the substitution, quarter mark for the answer, and quarter marks for the unit. So what's the total? What's your total?
1 mark.
What's your total? 1 mark. Suppose if you miss the second step, what will happen?
Quarter will be
A quarter will go on.
deducted.
Even though if your answer is correct, we will reduce quarter mark. So my dear, in this way, we will prepare the answer key. So you should be very, very careful. In midterm paper, most of the students, they did these things, but we already, some students, they came and cry. Okay, for both teachers, we considered that. But in the final exam, we are going to strictly follow these things. Once you write the formula, please, my dear, substitute the value in the formula. Please show everything. Don't try to give the direct answer. And please don't forget the unit also. Unit takes some marks. We are going to give some mark for the unit. Why you are unnecessarily losing your marks, quarter marks? At least if you write the unit for all the questions, at least you will get maybe 4 to 3 marks you will get for the unit. Am I right or not? Am I right or not? So
Yes,
please,
it is right.
don't try to lose even a quarter marks in the paper. My dear, listen carefully. I will tell you one important thing. Some students, they thought, okay, out of 60 marks, we got a 59. That means I'm closer to A plus. Okay, even though if you are very near to A plus, my dear, the final lab exam, final the theory exam will take the marks of 40. Am I right? 30 marks for the final theory, 10 marks for the final lab. So total 40 marks are still left. Anything may happen. If you did properly, for sure you will get exactly 40 marks. You will get A plus. Suppose some students, they are very closer to 60, and when the final finish, they are getting very low marks. So what will happen to your grade? What will happen to your grade, my dear? A plus 2, maybe sometimes you are very near to D. So you should be very, very careful. So without completing your final lab exam, please don't calculate your grade marks. This is not advisable. The only thing, prepare well for the theory as well as the lab, and after you attend the exam, after you did well, then you can calculate. Because some students, they send me the message, doctor, I am very closer to A plus grade, can you please help me? My dear, the system itself will be rounded your value, rounded your marks. Clear? Don't predict your grade before you complete your final theory and final lab. Anything may happen. May Allah protect you, and may Allah give you good chance for getting full marks in your final theory and the final lab. So unless you complete these two things, don't calculate your grade. This is my advice for you. Please focus on your final theory. Please focus on your final exam, lab exam, and try to get full marks in, because we are going to give a very good question and you will never suffer. If you prepared well for your final theory and the final lab, it will be very easy for getting full marks. Clear, my dear?
Doctor.
I think some students, just a minute, my dear, 1 minute. I think some students, they type, doctor, can we leave? My dear, why you want to leave? How many chapters left? My dear, actually, this is your 28th chapter. Inshallah, we have one period tomorrow, and I will start chapter number 29. And inshallah, next week, I will complete all the chapters. Clear? By next week, inshallah, I will complete 30 chapters. From 15 to 16 to 30, it will be in your head. So tomorrow, inshallah, I am going to start a new chapter, chapter number 29. And chapter number 30 is just 2 definition. And I'm going to open some videos for that 2 definition. Once you saw the video, you will get a clear picture. I don't want to explain these things. When you just saw the animated video, you will get the clear information about the 30th chapter. And only one problem we are going to solve in that chapter. Clear? So inshallah, tomorrow I will start chapter number 29, and inshallah next week I will complete chapter. What's the problem? What's the problem, my dear?
Sorry, doctor. I forget the mic.
Okay, no issue, no
Sorry.
issue. Okay, no issue. I thought something, what happens there. That's what I asked this question. Okay. Anyhow, my dear, don't worry about these things. Inshallah,
Doctor.
try to prepare well for your final theory and the final lab. Inshallah, still you have time, and please don't waste your time. And if you have any doubts regarding the theory, please come and visit my office during my office hour. My dear, once the final exam was closer, we will close the office room for preparing the question. So if you want to see the concerned teacher, please knock the door. Our office secretary will be call your teacher and he will come outside and see your, he will come and explain if you have any questions. Clear? Clear?
Doctor,
Yes.
Inshallah.
for class, for lab class tomorrow, we should wearing the lab clothes or no need?
My dear, this is our lab classes, so you must attend the classes with the proper dress code. Please, when you come for your final, when you come for the revision lab, please bring all your papers. And this is your revision lab. You are going to come and just revise by yourself because my part was already done. I explained all the experiment. I gave the marks for your experiment, everything I did. Suppose if you are absent for any experiment, please come and do that experiment, get some mark for that experiment. And the rest of the student, if you complete all the experiment, come and have a look. I will sit there. If you have any doubts, I will explain. I will not explain from starting to ending. It's your class. It's just a revision class for your preparation. If you have any doubts, ask me because I already explained everything. I gave the marks for all the experiment. And please, when you come for the revision lab, please bring all your papers and the papers what I give because I gave mark for each experiment. Am I right? So please bring all the papers. Yes, Mr. Nawab.
Yes, doctor. Some experiments have two graphs. It will be there in
Don't
the
worry,
final.
inshallah, my dear, listen carefully. When you come to the lab, I will give you the clear instruction. Okay. If you have experiment with two graph, I will give you the clear information in the lab classes. In your final
I
lab
mean in
exam,
the
you are going
final.
to draw. In your final lab exam, you are going to draw only one graph. Clear?
One
Inshallah,
graph.
when you come for the final lab revision lab, I will give you the instruction about your lab exam. Clear?
Okay, doctor. Very clear.
Clear, my dear.
Thank you so
That's
much.
it, my dear.
Yes.
Inshallah, see you tomorrow. Don't be absent, my dear. Those who are very closer to the end, you should be very, very careful, my dear. Inshallah, see you tomorrow. Clear? Assalamu alaikum.
See you, doctor.
Inshallah. Assalamu alaikum.
Thank you so much, doctor. Have a nice day.
You too, brother.